Hello everyone, welcome back to another discussion dynamics. Today we will close our kinematics of rigid bodies and we will close it with this subtopic, acceleration analysis. Plan for today is brief lecture review and then 2 examples. So let's dive straight into it. Brief lecture review. Let's assume that we have a rigid body, let's say such body. And let's say that we have 2 points on that body, okay? Point B and point A. And what else do we know? We know what is acceleration of point A, let's say here. We know what is alpha of the body. We also know what is omega of the body. Okay, so these are our knowns. AA, alpha body, and omega body. Plus we know, of course, one thing. We always know geometry, yes? So we also know this vector. RBA. So if you would like to know what is acceleration of body of point B on that rigid body, you should go for this expression. AA plus alpha body times RBA minus omega body squared RBA. Okay? We will use this equation today 45 times, okay? Or I don't know, more maybe. Any question to that brief lecture review? Okay, I don't see any, so let's do example number 1. Please familiarize yourself with the problem statement before we start our solution. Yeah, but I just asked you to familiarize yourself with the problem statements before coming to these discussions, yes? So let me start explaining what do we have in here. We have three bodies, yes? We have disk, we have beam BC, and we have beam CD. And we know geometry of everything. And they told us that alpha disk and omega disk are known, and they are equal to respectively 2 and 4. Yes, and omega rotates clockwise, and alpha rotates counterclockwise. And they ask us to find, oh, there is a mistake here. They ask us to find alpha CD. So alpha of this little guy. Okay, so in the pre-class assignment, that was, by the way, watched by only half of you. Yeah. So thank you to that half of you who watched that. We run velocity analysis for that mechanism, right? And we obtained there what was omega BC and omega CD. Yes. So even though they ask us to find the acceleration of this body, it doesn't mean that we should go right straight ahead into acceleration analysis. Yeah, because before running this acceleration analysis for this system, we must know, maybe let me start from beginning. Before running acceleration analysis of any mechanism, any system, you must know every single omega of the system. Okay. So that's why I pre-recorded that video, yes, so that we know what is omega BC and omega CD. And now we know every velocity in the system. Now we can run acceleration analysis, okay? Just keep that in mind. That was probably the most important sentence of today. Okay? So for example, on the exam, if you run your acceleration analysis and omega of certain body is missing, you can find that omega via running velocity analysis. Okay, just keep that in mind. Yeah. So if you are stuck on the exam and you don't know what is the omega of the body, then you just run velocity analysis. Okay. By the way, this is the most common question on the final. People usually tell me, "Hey, what is the omega of the body?" I don't know, but now you know. Okay. So if you don't know what is omega of the body, run velocity analysis for that body. Okay. Acceleration analysis. So in order to solve that problem, I would like to run acceleration analysis between E and F then B and F. So let's say not E and F, let's say F and E, okay, in this way, F and E. It doesn't matter, but it will look nicer on the picture. Then C and B, and then D and C. Okay, we're going to run for acceleration analysis. Okay, so let me write our expression from the previous board. So AF is equal to AE plus alpha of certain body. Think which body is that? RFE. Minus omega of certain body squared, RFE. Okay, and I'm just going to copy paste this expression 3 times. And I'm just going to change the subscript. Here, here, and here. Okay, and I will just change the subscripts. So in here we will have B, F, B with respect to F, and B with respect to F. In here we have C, B, and C with respect to B, C with respect to B. And in here we have D and C. And analogically, we will have D with respect to C and D with respect to C. Okay, guys, anybody want to help me? What body, what subscript I should put here and here? In other words, what body points F and E belong to? Disk, exactly. Okay. Disk, disk. And here, B and F also belong to the disk. And points C and B belong to bar BC. So I will put BC in here and BC in here. And points D and C belong to bar CD. So I'll put CD in here and CD in here. Okay. Any questions so far? So we're gonna run exactly the same thing 4 times. Okay? Let's start from beginning. Okay. Let's start with acceleration analysis between points F and E. Okay, guys, so let's look closer at, you know what? Maybe let's also put this link. So let's put this linkage here. So we're gonna start with this acceleration analysis, then we're gonna go here, then we will go here, and then we will go here. Okay, so this vector, this is R f with respect to E. This vector is b with respect to f. This vector is, of course, c with respect to d. And this little guy here is d with respect to c. Okay, so I made a mistake here, yes? It's c with respect to b. Sorry. Okay, so we're gonna just follow this link. All right, so let's focus on point F. Can you guys tell me? So actually, so AF will have AFX, AFY, and 0, yes? And AE will have AAX, AEY, 0. Can you guys tell me something? Can you guess some of their values? Yeah. So, for example, point F, okay? Point F, let me scrub the board. Can you tell me something about acceleration of that point? There's no slip condition, by the way, between ground and point F. Do you know its components? Trevor? They all be 0. Partially correct, 50% correct, yeah, AJ? Yes, that's true. So AJ is right. So this one will be 0. And the other one we don't know. If I ask you for velocity, Trevor, so velocity of point F is 0, yes. Velocity of F is 0. But not acceleration. It might be 0, but we don't know. For sure, tangential will be 0. Okay, how about E, point E? So this point. Yeah, okay, I see that you know.
Only in the X.
Only in the X, yeah, because this is the trajectory of point E. Do you see that? Point E has to follow that line. It cannot leave that line, yes? So EY will be 0. Great. Oh, sorry. Plus, what was alpha disk? Let me scroll the board. 002. Okay, and now this guy, RFE. It's here. RFE is here. So its components will be 0 minus R, 0. 0 minus R, 0. Minus, what was omega disk? Minus 4. But it doesn't matter because it's squared anyway. Yeah, so I can put here minus 4 or plus 4, doesn't matter. 0 minus R, 0. Okay, let's do this determinant. So that would be IJK 002, 0, and R was 0. It was 2, I believe. Yes, it would be minus 2, 0. So this would be 400. Great. Let us see. Let us sum up what we have so far. 0 AFY 0 is equal to AEX 00. Oh, sorry, AEX plus 4 plus 32. Okay, so we see that AEX will be minus 4 feet per second square, and AFY will be 32 feet per second square. So you see, Trevor, it's not 0. Yeah, but you can. So okay, let me draw it also vector-wise. Vector-wise, we have AE will be equal to minus 400 feet per second square, and AF will be 0.320 feet per second square. Yeah, but you see, Trevor, why it is not 0, yeah? Because that point F has to, it will have centrifugal acceleration, yes? If you look at the board, look, this is that AF, yeah? So that disk rolls, yeah? So AF will have centrifugal accelerations for sure, yeah? Pointing towards the center. Yeah, cool. I hope you are on the same page. Oh no. Okay, any questions so far? We are done with this. And we know accelerations of 2 points on that disk. Any questions? We good? Okay, so let's do exactly the same for different pair of points. These points. Okay, so VB we just found, yes? VB, AB. What I'm doing? Oh no, we don't know AB, sorry. AB we don't know, but F we found. So AB is equal to this vector plus 002 times this vector. Okay, I have to scroll up the board again and just to see RBF. Okay, RBF is here. Its components will be RR0, I believe, yeah? So that will be RR0 minus 4 squared RR0. Okay, if you guys do this determinant, you will obtain, I bet you know how to do the determinant, yes? If you do this determinant, you will obtain minus 4, 4, 0. Okay, so let's put everything together. AB will be equal to minus 4 minus 32, 32, 4 minus 32. Great. So we can cancel this out. And our AB, acceleration of AB will be following. Minus 36, 40 feet per second square. Does this make sense? Let me scroll the board. So alpha rotates this way. So yeah, it makes sense. Alpha body will be this way and this way. It makes sense. Kind of. Okay, anyway, we are done with 50% of our problem. Let's do now acceleration analysis between this pair of points, C and B. And we are getting closer to our solution. Yeah. So now, AC we don't know. AB we just found. And now this alpha of bar BC, we don't know that alpha BC, but let's assume it rotates counterclockwise. Okay. Assume counterclockwise direction, positive direction, times this vector. Okay, so I have to scroll up the board again. RCB. RCB is here. Okay, so we know the length of that vector. That length is 10. And we know the slope. Yes, slope is 3 units downwards and 4 units towards the right. Yeah, so I think that the best way to find that vector is if we draw this Pythagorean rectangle. I hope you remember that from probably even primary school, maybe, or middle school. 3, 4, 5, yes? This is Pythagorean triangle. And if we multiply it by 2, we'll end up with triangle 6, 8, 10, yes? And just by the way, our RCB has length 10. RCB, no, RCB? Yeah. Yes, RCB has length 10, yeah, and this slope, So you can clearly see that our RCB has to have these components. 8 minus 6, 0. Minus omega BC, let me scroll up the board, it's 1. It's here, by the way. Yeah, and we found it in our velocity analysis. That was your pre-class assignment. We found it in velocity analysis part. Okay, and in here I have to multiply light by the same vector, 8 minus 6, 0. Okay, guys. Oof. If we do this determinant, we'll obtain following expression. So if we do this determinant, we will end up with following vector. 6 alpha BC, 8 alpha BC, 0. Okay, let's put everything together. AC will have following expression. Minus 36 plus 6 alpha BC minus 8, and 4 plus 8 alpha BC plus 6, 0. We can simplify that and obtain minus 44 plus 6 alpha BC, 10 plus 8 alpha BC, 0. Great. We are done with 75% of the problem, and we cannot squeeze anything else from AC. We must leave it in that form right now. But we will solve what is alpha BC soon. Any questions so far? Are we on the same page, guys? Yeah? Okay, cool. So let's finish that problem by doing exactly the same for the 4th time. Okay, so now... Oh, come on, why you're not listening to me? I'm talking to my computer right now. Okay, you don't want to? That's fine. Okay, so let's do for exactly the same thing for the 4th time. Oops, sorry. Now, acceleration analysis between D and C. And I need some help. Very easy question to you guys. What is acceleration of point D? What is this value? Yeah, let me scroll up the board. Yeah. Point D is here. You all can see that it is fixed, yes? And Brian is showing me that the acceleration of point D is 0. Okay. So this is due to D being fixed. Okay, so we can write 0 vector is equal to exactly what we've just found. So this part. Plus our unknown vector, 0, 0, alpha, CD. Let's assume positive direction, times this vector. Okay, so for the last time, I will scroll up the board. RDC. RDC is here. and its components are 0, minus h, 0, and h is 2. So it will be 0, minus 2, 0, minus, oh my goodness, this value squared. I forgot what that value is, sorry. It's minus 7 or 7, doesn't matter, it's squared anyway. So it will be 7 squared times the same vector. Okay, this determinant, if you do, you will obtain that this is equal to 2 alpha CD 0, 0. Okay, let's recap everything. 0, 0, 0 is equal to minus 44 plus 6 alpha BC plus 2 alpha CD, 10 plus 8 alpha BC plus 98. Okay, we can simplify that. Oh, 108. Okay, so you can clearly see that we ended up with two equations and two unknowns. 0 is equal to minus 44 plus 6 alpha BC plus 2 alpha CD, and 0 is equal to 108 plus 8 alpha BC. Two equations, two unknowns. If you solve them, you will end up with alpha BC equal to negative 13.5 radians per second square, and alpha CD equal to positive 62.5 radians per second square. Okay, vector-wise, alpha BC will be 13.5 K radians second squared, so that would be clockwise. And alpha CD will be 62.5 K radians second squared counterclockwise. The end of the problem. How did you like it? You didn't. Me, I didn't like it. Oh, it's okay. I didn't like it either. No, I like it. But it's tedious. Yeah, it's tedious. Easy, but tedious. Yeah. Any questions? Should I tell a joke maybe to wake you up? Yes? Okay. Maybe. We have 20 minutes. Okay, if we have time after the second problem, I will tell you a joke. Okay? I will tell you my favorite joke. Okay, guys. So Trevor actually had a good question on Wednesday. So remember that Wednesday discussion, which approach you prefer better, velocity analysis or instantaneous center of rotation approach? Yeah, me too, actually, yeah. But if you like instantaneous center of rotation analysis, I mean, instantaneous center of rotation approach, it's fine with me. I personally prefer that vector approach, yeah, because it's less likely to make a mistake, yeah. You basically work like a robot, yeah. You just follow these equations, and yeah, with instantaneous center of rotation, it's like a geometrical approach. You have to draw a drawing. I don't like. I like this approach more, yeah. Even though it's tedious, it's more effective in my opinion, yeah. So yeah.
When we did our velocity analysis, we did d with respect to f, c with respect to b, and then d with respect to c. And then acceleration, we did f with respect to e.
Yeah.
How come we didn't do f with respect to e during the velocity analysis?
Because it was not needed. Yeah. Observe that. What's the velocity of point f? 0. Yeah, you solved. So you did it. You solved the fourth part. Okay, like that, just like that. Yeah. In here, we didn't know what is the acceleration of point F. Do you see? We had to run that. We had to run that additional analysis. Great question. Yeah, I was actually expecting that somebody will notice that. Thank you. Okay. Okay. Without further ado, let's do example number 2 because I want to tell you a joke afterwards. Okay, example number 2. Please familiarize yourself with the problem statement before we start our solution. Okay, so what do we have in here? We have only one body. And that body is moving on this rod. And we have one rope wrapped around our cylinder, yes? And the end of that rope has velocity d and acceleration d. By the way, one correction. We have 2 points d on the picture. So that's called center of that cylinder point Q, okay? Let it be point Q, okay? We know the geometry. We know geometry of the system. We know that the velocity is 8 inches per second, and acceleration of point D is 30 inches per second. They asked us to find accelerations of points A, B, and C. Solution? In order to find acceleration of these points, we also must know omega of the body. Is omega of the body known? No. Unfortunately, we must run velocity analysis first. Between, and maybe you guys can tell me between which 2 points we should run that velocity analysis. B and C, A and Q, D and C. There is one pair of points that if we run the analysis between them, we will solve it right away. In other words, velocities of which points you know right away. Mia, do you want to go for it? No. D and B. They have the same velocity, by the way. B has the same velocity as point D. Okay, but you found first point, yeah? So B will be first point. Okay. So B. Q we don't know because Q has the horizontal one, yeah? However, it's okay to run probably. It will be good, yeah? But we know. Yeah, A has 0. Yeah, great. Thank you, guys. Yeah. But by the way, Thomas, if you do B and Q, I think you will obtain the same result. Yeah. Okay. Velocity analysis between B and A. Let's do that. Yeah. Okay. In my notes, I have between A and B. Okay. Let's flip them. Okay. Not between B and A, but A and B. Okay. So let's do VA is equal to VB plus omega body times R A with respect to B. Okay, and you guys told me that this guy is 0 because it has no slip condition. So we will have 0 is equal to, I believe, -8, 0, 0 plus 0, 0 omega body times that vector. Okay, let me draw it in the picture from A to B. So this one. So this is RAB. So this one will be 0, 0 here, 5 minus 3. So let's do that maybe. 0, 5 minus 3, 0, 0, 2, 0. This is our vector. Okay, if you run this determinant, you will end up with -2 omega body, 0, 0. So our VA can be expressed as -8 -2 omega body, 0, 0. Okay, so our omega body is equal to 8 divided by -2. This is -4 radians per second. Great. And vector-wise will be 0, 0, -4 radians per second clockwise. Yeah. So I think you were right, Tom. If we do between B and Q, or A and Q, we will end up with it also can be solvable. Yeah. Because you said that velocity of point Q has only this component. Yes? Yeah. Also maybe not, yeah. So I'm wrong. I'm wrong. Yeah, okay. I told you I'm at least 7 times wrong every day. So this is one of those times. I still have 6 to yeah, you're right. So I'm wrong, you're right. Yeah. So that's what I said during the last 20 seconds. Forget about it, okay? Forget about it. Okay. Now acceleration analysis. Between, let's say, points A and B. Let's find alpha of our body. So I can write AA is equal to AB plus alpha body times RAB minus omega body squared RAB. Okay. So can you guys tell me something? I want you to help me once again. So I would like you to look at point A and tell me as much as squeeze something from that, okay? AA. So point A is here, yeah. And I would like to restate my question. So in this problem, we have to find these 6 values, yes? These two, and these two. Okay? AA, can you please tell me something about these values? Just by looking at the picture, can you guess their values? Yeah. You are very active today. Somebody else? Josh? Yeah. It will be? Yeah, that's true. Okay, but we will get there, okay? I see. Okay. It's 0. Yeah. How about point B also, yeah? How about something about point B? Can you tell me something about these 2 values? Yeah, that's good. Yeah. Especially about that value. Yeah, so it will be -30. Yeah. -30, because acceleration of point D is 30. Great. And you're right, Josh. You solved the problem faster than I did. Yeah, it will be -45 or like 45. Yeah, we'll see it in the second. Yeah, so it will be 0, AAY 0, and this is equal to -30 ABY 0 plus, I think we found it. Oh, no, we didn't find that vector. It will be 0, 0 alpha body. Just let's assume counterclockwise direction times 0, 2, 0 minus 4 squared 0, 2, 0. Okay, if you solve this determinant, oh, by the way, trick for you guys for the exam, just to save some of your time on the exam. Please observe that this determinant is exactly the same as this determinant. This determinant is exactly the same as this determinant. Okay? The only difference is that in here we have omega, and in here we have alpha. Do you see that? Yeah. So you can save your time on the exam. You can just calculate it twice. Once. You can just calculate it once, because the answer for this one will be -2 alpha body 0, 0. Yeah, it will be exactly the same answer. Just replace omega with alpha. Okay? Just to save some time. Was that clear what I explained? Yeah. Yeah. I told you that my goal is to help you, like to make it easier. Yeah. Okay. So let's put stuff together. Let's recap. So in here we have 0 a y. Zero, and this is equal to -30 -2 alpha body aby -32 and 0. Okay, so from this expression we see that our alpha body is -15 radians per second square. Okay, so our alpha body vector wise will be -15 k radians per second square clockwise, and that's it. Yeah, and then we have this expression aay is equal to aby -32. Yeah, we cannot squeeze anything else from this right now. Yeah. Okay, but let's continue. Let's run acceleration analysis between some other pair of points. Acceleration analysis. Let's do maybe between A and Q. Okay. Before we do that, there is a question.
Do you use like v squared over the radius of y?
You can. Yeah.
Oh.
Yeah, and I'm gonna do it right now. Yeah. So you did rotation. You did rotation about fixed point. Yes. I'm gonna do it with acceleration analysis. Yeah. Yes, and we will end up with the same. So what we should end up with? 45. Yes, because radius is 3, and alpha is 15. Yes. So yes, you're right that we should end up with 45. I'm gonna put 45 in here. Okay. This guy should be 45. We'll see. Okay. So in here I will just write AA is equal to AQ plus alpha body times RAQ minus omega body squared RAQ. Okay, so in here you guys told me that that will be 0 AAY 0. Then Thomas told me that AQ will be just this vector. AAQ 0, 0, yeah, because the trajectory is here. This is the trajectory of point Q. So it's 0, its y component has to be 0. So AQ has to have AQ 0, 0. And we just found this value, 0, 0 minus 15 times this vector. Oh my goodness, I must scroll up the board and I must draw this vector, RAQ. RAQ is here. RAQ. So that would be 0 minus 3, 0, right? Yeah. 0 minus 3, 0 minus 4 squared, 0 minus 3, 0. Okay, this determinant, if you do, you will obtain $45. So it's promising. 0, 0. And in here we'll end up with 0 AAY 0. And this is equal to AQ plus 45. Oh, minus 45, yes? Minus 45. Sorry, guys. Minus 45. Yeah. And in here we'll end up with 48. Great. So we already see exactly what Josh and Tom said. AQ is 45 inches per second square. And this is 48? Ah, yeah, okay. My mistake from the beginning, yeah. 48 inches per second square. And this is, yeah. So I didn't mean to say 45 earlier. I meant to say 48. Sorry. But you also didn't correct me, so it's also your fault. And your fault as well, Josh. I will. Okay. So yeah. So we found this value. So we found this value. Okay, sorry guys. So this one will be 48. Yeah, which makes sense because it must be pointing upwards. Yeah, it has to have centrifugal acceleration. Okay, and now let's find this guy, ABY. ABY can be found from this expression we left at some point. Oh no. So we know that this guy is 48. So that means that ABY will be equal to 80 inches per second square. Great. So this will be 80. Okay, and we are left with these two values right now. Before we do them, I'm not gonna do them because it's already 10:50. Can I steal 1 minute and a half from your precious time? Okay, 90 seconds. Okay. Are there any questions so far? Yeah. If you have a question, I will stay after the discussion. Okay. Bear with me for 90 seconds. Okay. So now the question is how to find acceleration of point C. Surprisingly, we will do exactly the same for the 17th time today. Yes. Okay. We will just do acceleration analysis. Between which points we want, guys? C and B or A, whichever. I don't know. Let's say C and B. Okay, C and B. Okay, and if you do that for the 17th time today, you will end up with AC is equal to minus 35 minus 75 0 inches per second squared. Okay, and that's it when it comes to such problems. How does it look like from your perspective? It's okay? Cool. So thank you for today and happy holidays. Bye.